Hey everyone, welcome to another episode of the AI Forecast, a weekly podcast sponsored by the amazing folks at Cloudera. I'm your host, Paul Muller, and every week we explore the past, the present, and the future of data and AI in the enterprise, along with leading companies and industry thought leaders. Now, before I introduce today's guest, a huge thanks to everyone who sent us messages and feedback. It's hugely rewarding to hear from all of you. If you have been enjoying the podcast so far, we'd love it if you drop a cheeky little 5-star review on whatever podcatcher you're happening to be listening to us on. And of course, make sure to like, share, and subscribe to keep those algorithms happy. Now, speaking of algorithms, today's guest is Peter Norvig. He's a distinguished education fellow at Stanford University and the author of multiple books on the topic of AI, including Paradigms of AI Programming, first published, now hold on to your hats, folks, assuming you're wearing one, in 1992. I think it was described as one of the most hardcore books on AI programming ever published. And more recently, Artificial Intelligence, A Modern Approach, which is now in its 4th edition and has gone on to become one of the leading textbooks adopted by over 1,500 academic institutions globally. Now, Peter's insights come from decades of experience, including his roles as Director of Research and Search Quality at Google, and before that, Head of Computational Sciences Division at NASA. He joins us today to share his thoughts on AI literacy, the disruption in the education industry. I'm going to ask him why you can't learn to program in 24 hours, if you can remember writing that blog post. And I'm hoping he'll shed some light on the shadowy group of researchers at the Lego Institute for Lego Investigation. Yes, I have been doing my research, Peter. Welcome to the podcast, Pete.
Great to be here. And you certainly have been spying on me.
Well, it's not hard. You've published pretty much, I won't say every thought you've ever had, but you clearly like to put your thoughts down in writing.
That's right.
I love it. All right. Well, hey, look, before we get into your musings, we do a little thing at the beginning of every podcast. We could call it the Fast Four, or we could call it Lightning Round. But basically, it's a chance for our audience to get to know you through a slightly quirkier lens. Are you ready to play the game?
Ready to play. Let's go.
Let's do it. All right. First up, what would people who know you best say is your superpower?
I can explain complicated things in a way that's as simple as possible, but not one bit simpler.
All right, well, we'll put that to the test today. You've obviously been in technology a long time, at the heart of it, really. What would you say the most impactful technology of all time was?
I think especially what we're seeing in the last couple of years has proven to me that the most important technology of all time is the written word. And all our culture, up to including large language models, stems from that. Now, some people would say the spoken word was important. And yes, you can have tribes and you can have a small bit of culture that's passed on that way. But in order to make progress and have future generations really build on the past, you need the written word.
There's a lot of talk about what AI is going to do for disrupting industries and, any number of predictions about the future. We're going to talk about some today, but just on a personal note, what would you like to see AI automate for you in your future?
I want to automate the hours that we waste doing things that we don't like to do. So I want to free up our time to allow us to enjoy life more so that we can be kinder and more helpful to others.
Last but not least, you've obviously worked a lot with data in your past. I'm sure you've seen budding graduates enter the workforce and have all sorts of thoughts about what they were going to do. And you've had to stop them and say, hey, guys, when you start working with data, I've learned a couple of little things that you didn't learn in your university course. What are some of the hacks that have helped, or best practices that have helped you work with data best?
I think the biggest thing is to understand that the whole pipeline is important. And there's this famous paper that says everybody wants to do the model work, come up with the fancy algorithm, the fancy new model, and nobody wants to do the data work. Figure out what data is necessary, how to clean it, how to get a nice pipeline to update it and when to update it, how to make sure that it's representative of what you really want it to represent, and that it's not being gamed or riddled with misinformation and so on.
Well, it's a good segue to, you've dealt with a lot of data in your past. I sort of briefly glossed over your background. Tell us a bit about how you got to be here.
I'm, as you alluded to, I'm an AI hipster. I was doing it before it was cool. And I was fortunate going to high school in the late 1970s. We happened to have a computer at my high school, which was unusual at the time. And so I got to learn to program, and that was awesome, and I really took to it. And we also had a linguistics class, and that was, I guess, unusual for a high school. And I took those two classes, and I went to the two teachers, and I said, it seems like there's something in common between the rules that we learn in linguistics and the rules that we learn in programming. Could those two things be put together? And the teacher said, yeah, that's an excellent idea. We don't know enough to tell you how to do that, but maybe you can figure it out on your own someday. So I did that, led me to eventually to grad school at Berkeley. I thought I was going to have a career as a professor and started down that path. So in the mid 80s, we didn't quite yet have the word big data, but I knew that's what I wanted to do. And I knew that as a young assistant professor, I couldn't get the resources I needed. I couldn't get the data. I couldn't get the computing power. I couldn't get the more than a couple of grad students. And so I moved over, swapped out my .edu for .com, worked at companies small and large. Google was an example of both of those, and ended up where I am today.
I want to. I'm resisting every temptation I can to jump down a Gödel Escher Bach discussion about Doug Hofstadter's famous book, of course.
Yeah.
Let's bringing it back, talking about I suppose groundbreaking books. A Modern Approach is now known as one of the leading textbooks used for AI education. What inspired you to, I guess, go from writing a hardcore tech book like your book on AI programming with Lisp to this?
Yeah, so it was in, I guess, 1991. I was at Berkeley, and the AI faculty there would, we'd go out to lunch together, and we'd say, there've been really good textbooks in the field of AI, and I had grown up on those, but we felt like the field was moving, and then the books were becoming obsolete. So which ways was it moving? One, we were moving from logic to probability. I think AI started because people said, well, computers are all about numbers, but human thinking is about logic, so let's try to do that. And then over time, we said, well, you can only get so far with logic. There's only so many things that are Boolean, true or false, and most things are uncertain. And so AI was shifting towards dealing with probability. There was this shift that we talked about a little bit of going from saying algorithms are the most important things to saying, well, maybe data is just as important or maybe more important. And so that was a big shift. And there was this shift from the earlier days of hand-coded expert systems, where in order to figure out how to do something, you'd go out and ask an expert, go to a doctor and say, how do you diagnose this case? And sort of try to write down in code what they do. And moving away from that towards an approach of using machine learning rather than using hand coding. And so we came along and said, all these things are changing. There should be a new book. And we kept on talking about it, and nothing happened. I actually ended up going off to industry as I talked about. And a year later, after I'd been at Sun Microsystems for a year, I ran into Stuart Russell at a conference, and I said, that book Roe was talking about, you guys must be halfway done with that by now. And he says, no, we never actually got started. And I said, well, let's do it. And so we did it. And it was an example of remote work, which at that time didn't mean that we did it with video conferences like this. It meant we did it by FTPing files back and forward.
I love it.
The first version came out in 95, and we thought, if we're lucky and we did a good job, this should be the textbook for the next 5 or 10 years, and then somebody else will take over. And for better or worse, nobody else took over. So here we are 30 years later, still having to do it.
And it's quite a tome at 1,000 pages. It's got quite broad coverage. When talking about the topic of, quote unquote, a modern approach to AI, how do you set the boundaries for that? Because I mean, you literally could go all the way through to, business applications and use cases down to the fundamentals. How did you figure out how to scope it?
Yeah, it's hard, and it's especially hard now, and so that's why you see there isn't a fifth edition. So even though the book's only a couple of years old, this edition is more out of date than any other edition has ever been, because the rate of progress is 10 times faster now than it's ever been. I think when we started, we really kind of focused on computer science students, first for those students who were going to go to grad school in AI, but also for every computer science student, and maybe a few students from other fields, other related engineering type fields. But now I think it's quite different. And now every computer science student, and in many ways, everyone who lives in the modern world, should be educated on how to use AI and how it affects them. I think, if we were to do an update, it would have to be quite different, and maybe that can't all be done in one book. Maybe there's multiple different books, and I also kind of feel like, as some of the work I've been doing, maybe the whole idea of a book needs to be updated with something that's more interactive and more personalized.
Yeah, I suppose the way we're learning itself seems to have changed quite radically. So maybe we'll start at the AI specific level and open the aperture to the changing face of education. But just specifically, how would you characterize the state of AI education today compared to what it was? Going back to 92, I remember myself looking at expert systems and so forth at the time and just thinking it all kind of reeked of almost futility. Like, we'll never have enough compute. We'll never have the right kind of compute. We'll never be able to get a computer. The whole idea of the singularity just seemed like science fiction. So I imagine the whole process of education has changed, but maybe it hasn't.
Yeah, I think that's definitely true. And so you're right that a lot of what we were trying to do back then really wasn't practical because we didn't have the computing power to do it. And we tried to kind of ignore that and push ahead anyways. And I remember the day, and it was probably 1981, when I was a grad student at Berkeley, and Jeff Hinton came and talked about his latest research in neural nets. And, we've been doing this good old-fashioned AI sort of expert system-like. And we said, this sounds great. Let's go back into the lab and build it. And of course, there's no GitHub then, there's no software to download. You have to build everything from scratch. So, we take a day or two and build something, and it works on toy problems. And we give it a real problem, and it runs overnight. It doesn't converge to an answer. We let it run the second night, still doesn't converge. And then we just threw it away and said, this stuff doesn't work. And I wish I still had that program, because I could probably run it on a GPU cluster now, and in a second I would have the right answer. And so that's a big change. I think there's also a change that there's just so much going on, right? So when I was a student, you could keep up with everything that was happening. I remember going to the library at my university, and the call letters that I was most interested in, I remember, was QA 76. And you go to there, and there's a shelf of books that's about 3 feet long, and you can read all those books. And that's all there is. There's nothing else available. And, maybe then you could start reading some research articles, and they come out slowly once a year. And now it's every week there's a dozen new papers of exciting breakthroughs. And so you can't keep up with everything. I think we try to say we're building what we think is this shared knowledge of here's how our field has evolved, and here's what everybody should know. And I feel like that can't really be done anymore because, one, there's just too much of it. It goes in too many different directions. And two, it changes so quickly. And that, if you thought you were finished with a book this week, next week, there'd be something new. Mm-hmm. So we need something that's more interactive, more focused on what you're interested in, more continual learning rather than saying you're going to learn this specific thing and then you're done. Right. So I don't like this idea that, we've come to this system where you go to a college for 4 years and then they give you a piece of paper that says you never have to learn anything again for the rest of your life. You're certified. Mm. I think we want to change that to a model that's more continuing education for your continual changing, evolving needs, and for the evolving knowledge that's coming out every week.
Yeah, the notion of lifelong learning, I suppose.
Yeah.
And I mean, we're in this odd, speaking of the nature of education, we do seem to be in this odd feedback loop where AI technology is kind of like the snake eating its own tail. You know, if I want to understand how to do something, weirdly enough, including how to write AI software, I'll ask the AI.
Mm-hmm.
Do you see this as being, well, I suppose, how do you see that playing out as we iterate over that on that for the next, 5-10 years? There's a number of people saying these tools it's a bit like introducing a calculator into a maths class. It's going to make people dumber. You get those folks who are saying it's going to enfeeble the human mind, and others saying it will do the opposite. What are your thoughts?
So I think it's very interesting, and I think we don't know where it's all going, right? So you see when somebody is very skilled, like an Andrei Karpathy starts showing the videos of his vibe coding, he's successful. But it's not because he's handed everything over to the AI. It's because he had a pretty good idea of what he wanted to do and what was possible and what was not possible and how programming works and how AI works and how all these components work. And then he's getting it done faster by having the AI guide a path through that. But I think if you didn't know any of those things, it'd be too easy to go down the wrong path. That you ask the AI something and it doesn't quite understand what you mean and you don't quite understand what you want, and you end up in the wrong place. So I think having these core skills and competencies and understandings is crucial to having this partnership work. I think it's just like, if you gave me a chainsaw and said, go out and cut down this forest, I'm much more likely to injure myself than somebody who's got skill using those tools.
Well, and I brought up learning to program in 24 hours, which was a callback to an essay you wrote. And I'm not sure at the time whether you were thinking about the confluence of vibe coding and but if you think about it, what you wrote, because for people who haven't read it, your essay is actually titled "Learn How to Program in 10 Years," and it was really kind of the anti-pattern, describing the anti-pattern of those popular books that say, learn how to do whatever in 24 hours. But the central tenet of what you were writing about was it's not really the ability to write the code that's important; it's the ability to have judgment as to how and where to apply different techniques. Do you want to elaborate on what you meant by that essay?
I think that's right. So I think in some sense, maybe this word of programming or coding is ambiguous. And one thing means able to write some text that compiles, and another is to have deep understanding of what's going on. Right? And so anything that says, I'm going to teach you how to do this in 24 hours is not going to give you a deep understanding. And what I was trying to say in this essay is it's the deep understanding that really matters. And I used 10 years after this Ericsson results of saying many skills take about 10 years to develop. I don't think you should take that exact number too literally or seriously. It can't be that everything takes exactly 10 years. It must be some skills are easier than others. But it takes a long time to understand all this, and it takes deliberate practice of going through problems and working it out and trying to do just the right thing. And we have had, even before AI coding, we had a big push for this. Everyone should learn to code, and I wish they had. I think it's great, and I think it's a great skill, and I really enjoy doing it, and I can do more powerful things because of it, and I think a lot of other people could too. But I wish they didn't emphasize just coding. I wish they would say, learn to problem solve and learn to create models and work with them to gain a better understanding, because that's really what's important. And I think it's less important whether you learn the syntax of a programming language or you have some AI tool that helps you do that. What's important is you learn this process of how do I define a problem? How do I scope out what's important? How do I go towards a solution? How do I see errors and recover from them? All those skills are really important. And, where you put the semicolons in your programs is not as important.
So if I could maybe draw a parallel, and please correct me if I've gotten this wrong, what you're saying to me sounds analogous to the idea that teaching English to a lawyer or math to an accountant, neither math nor English makes a lawyer or an accountant.
Right.
It's the corpus of knowledge around that, how and when to apply what principles, how to detect when fraud's occurring, how to, et cetera. Those are the things that make you talented at that. Would that be a fair analogy?
Yeah, I think that's right. But you still got to have the math, right? So if you make a subtraction mistake, you're still going to make an error, even if you understand the principles. But if you don't understand the principles, you're worse off.
I've got a bit of a non sequitur, and then we'll get back to this topic of education. Maybe it's not a non sequitur, because I think one of the other things that's occurring is we started to the term AI has become common parlance for literally everybody, but what we mean by it is often different. The term gets bandied around quite a lot. Just curious, well, A, do you agree, and B, what does AI mean to you?
In our book, we said AI means making better decisions to accomplish your goals. But of course, lots of other fields have that as a goal too, right? So economics kind of is the same idea, maximizing expected utility, and general software engineering is you want to make programs that are correct and don't have bugs. That's better than programs that don't. So to me, the difference, say, between AI and regular software is in the types of problems that you deal with, and somewhat in the methods that you use, but more so really in the types of problems. And I think in regular software, the main enemy is complexity. So, I'm tasked with writing the software for a bank, and that's hard because there's thousands and thousands of different rules and taxes and regulations and fees, and I have to get everyone right. But if I get it right, then there is a correct answer down to the penny, and I can see if it's right or wrong. Whereas in AI, I think you are dealing with complexity, but the main enemy is uncertainty. And that's in part because of the techniques you use, but it's more so because of the types of problems that you deal with, right? So we're asked to say, identify what's in this image. And so is that Uncle Frank or not? Well, there may not be any ground truth. Nobody knows for sure if it is. Is that a wolf or a husky? Nobody knows for sure. And yet you have to come up with an answer. There isn't a definitive way to say, yes, it was right or wrong, but you've got to deal with that uncertainty. And so I think that's what AI is, that the techniques we've built can be seen as this approach to try to deal with problems that are more complicated and deal with uncertainty. Whereas, mathematics and traditional programming dealt with problems that are hard, but had absolutely correct right and wrong answers.
Yeah, so let's talk about that, I think, really important shift. And I'll use the calculator as an example. It would be rare to find a calculator that gives you an incorrect result. That's still in production today, I should say.
Yeah, they round off in the last digit, but other than that, right?
Yeah, exactly right. Some corner cases around floating point and really big numbers, but fundamentally, when a math error occurs at a logic level, I think Intel had a floating point bug thinking about it 30 years ago. It makes the headlines, certainly at least in the industry journals, because we've come to trust so much in the result, and that goes to the psyche of the user. Like, you don't question the number you get out of the calculator. It might question the method, but not the result. Because of artificial intelligence's association with the computer, do you think that we run the risk, and I'm thinking specifically of like school children and lay people, of conveying too much trust in the result we get because of computers involved?
Yeah, I think that's absolutely true. And it's true for AI. I think it's true without AI, that we kind of use this as an excuse, right? So, I've certainly had this frustrating experience, and maybe other listeners have, of, you call up service at some company and you say, look, you did this thing and it's obviously wrong. You should fix it. And they say, oh, I can't because the computer said so. Right? I can see it's happened to you, right?
Or too many times to count.
Right. And it's like, if we didn't have a computer, you couldn't give that for an answer. You couldn't say, no, I can't fix that for you because I don't feel like it.
That unfortunately has also happened to me.
Yeah. But you'd understand. Everybody would understand right away that there's something wrong with that answer. But when they say it's because the computer can't handle it, we just say, oh, okay, I guess that's it. I can't talk back against the computer.
Yeah.
And I hope we can get past that. And I hope maybe the types of AIs that we're building now, with these language models as an important part of them, maybe they'll be more flexible and they'll help us get around some of those types of problems.
Well, and that's where I wanted to touch on the next area of topics. So we talked about education, sort of K through to 12 and into the university years. But another part of, I suppose, education, and it's related, is the learning we make through our mistakes. And I often see the regulatory process as a lagging indicator of the mistakes we make. And then the law puts guide rails around us to stop us making the mistakes again. Mm-hmm. When we think about policy as relates to AI and those heightened expectations combined with the conferred infallibility because a computer said it, how important is the role of AI regulation and, I suppose, limits or controls on just how much trust we do confer and convey to these things?
So I think the trustworthiness and safety is a really important issue. And I think regulation plays a role, but we shouldn't rely on regulation to be the only tool. So yes, there is a role for the regulators. I think there's also been an important role in self-regulation by the companies. So, all the companies have their sets of AI principles. And I've talked to peers at Microsoft and Anthropic and OpenAI and other companies, and they all take this very, very seriously. They say this is one of the most important things we do is deal with this safety and go by these principles. So I think that's really important. I think there's a role for third-party certification. So I joined an AI safety board that was set up by Underwriters Laboratory. And I thought they were an interesting company because the last time we had this scare where the public says, oh no, there's a new technology and it's going to kill everybody. It was over 100 years ago, and it was electricity, right? Everybody was worried they were going to get electrocuted because these new wires were all over town. And Underwriters Laboratory stepped up and says, it's okay, don't worry. If you see this little sticker on your toaster, it's probably not going to kill you. And consumers trusted that brand, and therefore companies voluntarily submitted themselves to this certification process. And I think in many ways a third-party, nonprofit, non-governmental organization might be more agile than a set of legislators in trying to deal with this. So I think that role of certification is important. Then I also think there may be a role for professional societies, and I'm not quite sure how that should go. So yes, I belong to the AAAI and ACM societies, and they have their overall set of principles and guidelines and ethics, and now they have specific sets for AI. And so to some extent, I'm bound by that. But by another extent, I get the membership so that I could get the journal, but it's not really an important part of my life. And in other industries, it is, right? So I get to call myself a software engineer just because I want to. And yeah, I have degrees, but anybody can call themselves a software engineer. I would not be allowed to say, you know what? I'm going to call myself a civil engineer, and I'm going to go out tomorrow and I'm going to build a bridge, right? They don't let me do that. Right? You've got to have official certification before you're allowed to build a bridge. And I don't want to put this on the whole software industry, but there might be some way to say, here's certain kinds of certain size or something of AI systems. And in order to build that, you have to be certified in some way as an engineer. I don't know if that's the right approach or not.
Yeah, it's an interesting thought bubble. I mean, just related, I mean, are there classes of problems that you would personally feel reluctant putting a probabilistic AI model in the loop on, or in control of, maybe I should say, rather than in the loop of?
There's certainly cases where you'd rather have it, sort of in the loop or on the loop. They talk about it in different ways. To the extent that things are important, you want more eyes looking at it. Mm. And sometimes you can do that, and other times you can't. Other times, the speed at which you have to make decisions is going to.
Yeah.
So I was at NASA, and they came to us and said, "We've got this sensor." This was before the second shuttle explosion. They said, "We've got this sensor looking at the flume coming out of the engines, and you can see a certain signature if there is some metal in there, and if there is, that means bad things are really happening. It's not supposed to be there. Maybe the crew should eject." So we looked at that, we did an analysis, and said, yes, we think we can detect when it's going to blow up about, and I forget the exact number, but it was something like 1 second ahead of time or 2 seconds ahead of time. And they said, no, thank you, because that's not enough time. What we wanted to do was put up an alert and have the captain press the eject button. And we said, no, we can't do that. We can't give you enough time to do that. We're going to have to be automated and do an automatic ejection. And they said, no, thank you. That's too important a choice. That needs to be under human guidance and control. And you got to give them enough time and enough information for them to make that call. And we said, we can't do it. So that was never done. And I think there are a lot of cases like that. And maybe you will start to change sometimes. So, if these automated systems prove themselves, you may get to the point where you say, here's a decision where we don't have enough time to have a human in the loop, but we believe that the automated decision is worth taking, that the risk of it getting wrong is less than the risk of not being able to make that decision. And absolutely. I think we do all those on a case-by-case basis.
So to that end, obviously, at least in the United States, your lawmakers play a big role in setting some of those parameters and boundaries for what is acceptable. You had the opportunity to run a boot camp or briefing for them. What was your experience? What's their state of being when it comes to this?
Stanford now, and I think they've done it 4 times, and I've been involved with the last couple of inviting in the U.S. and congressional aides for an AI boot camp. I think it was 4 days long. They come out to California because we found if we go to D.C., they're always leaving the room to go off and doing something vital. But if we have them stuck in California, then they stay longer. And I think that was useful. So one thing was, these are not the target audience of my textbooks. These are not computer science students. They're both not engineers. They're MBAs or lawyers or political scientists. But they were the ones who came were ones who are aiding Congress people who are on the science and technology committees and these other kind of committees where this is important to them. And I felt like they did a pretty good job of being up to speed. So that was useful. And I think they were interested in hearing about the technology, hearing about the different sort of ethical type issues involved, hearing predictions for the future, thinking about what they should be doing. I also did another one of these for state legislators, where they're trying to figure out what each state should be doing and what their responses should be. So I think people are taking this seriously. It was also interesting to me that, so we did it, probably 2023, and some of them said, this is the first time I've been in a room with a member of the opposite party since before COVID.
Extraordinary.
So, I think it's we want to be able to bring our government together, bring our country together and face these complex issues. And so I was glad we were able to do a small part towards that.
I mean, I think it's encouraging to see legislative bodies around the world do seem to be paying it close amount of attention, which is good. And as you say, it's going to be finding the balance in there that's important. Related topic, you mentioned at the beginning of the podcast the importance of the data pipeline. There seems to be a lot of focus being put on quote unquote AI, and you get the sense that the focus is on the algorithm and the output. Do you think enough attention's being paid both in industry and at a broader public level about the quality of data issues?
I mean, certainly there's headlines around issues with copyright and so on, and who owns the data. I think that's certainly important. There's issues around disinformation. Yeah, someone who's worked at Google for a long time, we have experience dealing with that. But I do think it's sort of surprising how long it took the public to be aware of that, right? So I remember back in early 2001 at Google, Al Gore came on board on the board of directors. He thought he was going to have a different job for the next 4 to 8 years, but that didn't work out for him. So he joined the Google board, among other things. And he came and he gave this inspiring speech in which he said, you know, you guys providing access to information, all the world's information, you're doing a great thing. It's going to make our society better. And he never once said, well, maybe you should watch out for misinformation. And it just wasn't on his radar. And he was probably the world's premier tech politician. You know, maybe him and Gingrich were the two who were most interested in technology at the time, and didn't come up for him. And I feel even for us, we were a little bit late to the party on that. So I think certainly from the very start, we had this idea of that there are web spammers out there, people who are trying to get to the top of the search ranking by nefarious means. And so we had that on our radar right from the start. But it took a while to say, oh, well, there are other people who aren't just trying to get to the top of the ranking, but they're trying to influence the public at large. And it took us a while to recognize that as a problem. So that's going to be a continuing problem. You know, in some ways, I think it's interesting because it's really a continuation of what I've been doing at Google Search all along. I'm saying we're trying to find high quality stuff and get rid of the low quality stuff. And we can do that by understanding what the sources say, understanding now what the content actually means. In the early days, you know, we could only do that by very vague pattern matching types approach. Now you can do that much better. We can get help from people taking rankings of what's high content and what's not. We can do more with synthetic data of generating new data. I think that's really interesting. So one of the exciting things to me is trying to understand to what extent we can simulate people. For a long time, we've been simulating physics in computer graphics. You know, that's what Pixar does, basically. We also do that, like, say, for the self-driving cars. Right. So in self-driving cars, it's like the first 1,000,000 miles are the hardest. You got to go out on the roads and actually drive and record all the data. But once you've gathered that amount of data, then you can start building a simulation that's pretty good. And, you know, you really understand well what happens when I hit the brakes on this particular road. It's a little bit harder to understand, is that pedestrian going to jump out into traffic or not? But we can build some of that. And in the past year or so, we're starting to see like economists saying, can I simulate an economy? Can I simulate a voter and how they're going to vote on this issue, right? So you give it a prompt, like you're a 37-year-old woman from Wisconsin with 3 kids and blah, blah, blah. How are you going to vote on this upcoming election? And they're saying, yeah, maybe those simulations are getting better. And understanding to what extent we can trust them and generate synthetic data, I think, is really important. For me, I'm really interested in, can we apply that to the teacher-student relationship? Can we, you know, for a teacher, simulate, well, if you did this move, how would the student respond? And it's much easier to get feedback that way. And a lot of what we do is driven on this idea of reinforcement learning. You try something out, you get feedback, did it work or did it not? And then you do better over time. And we've had great success in things like, you know, how do I get the student to answer this question correctly. Should I show him video A or problem B or paragraph C? We can answer that question. What we aren't good at answering is, how can we get the student to be interested and successful in this field 2 years from now? It takes us 2 years to gather that data. But if we could run a simulation, then maybe we could get that data in 2 days rather than 2 years. And that would be a huge advantage. So I'm excited about new ways of gathering data. One more thing I'm excited about there
Please.
Is the possibility of using video. Right, so we've seen this rise of chips from NVIDIA and others, and how we can build larger and larger models, have more and more parameters, more and more training data. But it's mostly been focused on textual data, which is very compact, and there are some image models, which are also doing really well now, and much less on video, just because there's so much more of it. And the processing demands of saying, can I train on all the YouTube videos in the world? It's such that you can't economically do that right now. But in another couple generations of processing power, you will be able to do that. And I think that's interesting for a couple reasons. And I think it gives you better understanding of what the world's really like. First, because you capture actions, but also because is sort of less biased, right? So everything that's written down is written because somebody thought it was important. And most of the photos that are taken were taken because somebody says, I'm going to click the shutter right now in this direction. And some of videos are like that, but other videos are just, here's a camera and it's running 24/7. So it's kind of the only source we have of a completely unbiased view of what the world is like, at least the physics of the world. And you have that, and you combine it with the other things you know, and then maybe you combine the physics with the psychology of the world, and then you have a better understanding. So just need to make our processors 1,000 times better, and that's always been true. And we've done it in my lifetime. We've made it 1,000 times better at least 3 times, maybe 4, depending on how you count. And we just got to do it one more time.
Well, if you don't mind, and feel free if I've stepped into an area where you have no particular point of view, then feel free to take a hard pass. But one of the rate limiting factors here appears to be not just computational power, but resource intensity. As someone once remarked, yeah, sure, you can teach a computer to beat a human at chess, but it takes energy generation facility, electricity generation facility to do that for the computer. The person had a slice of pizza for breakfast. The proportionality of energy intensity is completely out by orders of magnitude. But then when we use the word probability, of course, that invites at least to me, my thoughts immediately go to quantum computation, which relies on basically probabilistic underpinnings. Do you see an intersection of quantum computing and it being kind of the game-changing breakthrough in terms of energy intensity, or do you see it as a bit of a moonshot up there with fusion? It's 10 years away and always will be.
Yeah, I think nobody knows, right? And I just saw a post today from Scott Aronson, who's a computer scientist who specializes in quantum computing. And he says he was interviewed and the hosts were continually frustrated because he was explaining technical things and they just wanted to know, how is this going to affect the business bottom line over the next 5 years? And he says, well, I can't answer that. I kind of feel like, if you'd asked me 5 years ago, I said, I'm not following quantum computing because I'm going to be dead before it does anything good. So that's somebody else's problem. Now I'm not convinced of that. Now I say there could be uses of it. I think most of the things I want to do not seem well suited to quantum computers, right? So the kinds of things I feel like I want to do is I want to apply a very simple amount of processing to all the text on the web. And the things that a quantum computer wants to do is saying, I want to apply very complicated processing to 100 bits or something like that. So it seems like a mismatch. But there could be small pieces where it does play a good role. And we are seeing now, so a lot of the focus in the last year has been, okay, year before we built these language models and they're big and they got 1 billion parameters, but just having them generate the next word, that doesn't seem so great, right? This idea of you have a language model, and by definition, language model is what's the probability of the next word given the previous words, and to have it spit out one word after the other based just on a prompt, to me, that doesn't seem like artificial intelligence. That's more like an artificial politician, right? They're really good at, you give them a prompt and they'll spit out some words. But real artificial intelligence, that would be saying, oh, that's an interesting question. Let me think about that. Let me try 5 different approaches, compare which ones work, criticize them, run some external stuff. And only after I've done that, now I'll start talking. And that's closer to what these models are doing now. And so there's a push in more compute at retrieval time rather than at training time. And there might be a role for a quantum computer to do that. And I guess the other thing I want to say is I think these energy needs and this carbon footprint have been exaggerated. I'm pretty confident that we'll see AI as being a net positive because of the things that we'll invent through it. We'll end up with a net savings. And so a couple examples of that. One is you go back to 1945, the ENIAC computer fills a whole room. Let's say I time travel there and I say, in my time, everyone on the planet is going to have a computer that's 1 million times more powerful than this. And they say, whoa, well, let me figure out the electricity budget for that. No, that's impossible. We couldn't possibly do that. And yet we did, right? Because we figured out how to make them more energy efficient over time. So, and I think we'll do that again, right? And I remember a few years ago, before the big AI boom, there was an article that came out and says, oh, well, look at the power that Google is using just to do a search. And there was this comparison that says, I think it was one of these British outlets. And so they compared it to boiling a pot of tea, which is their standard unit of energy usage. And we wrote this rebuttal that says, no, you've got it wrong by a couple of orders of magnitude. And if you think of, you do one Google search and then you look at the results for 5 minutes, then there's lots of power going on. Yes, there's stuff going on in the Google data centers. And then there's energy generated by your body, energy generated by the lights in your room, energy generated by the heating or cooling in your room, and energy generated by your laptop. And every one of those is using up more energy than the Google search was. So it's certainly true that an AI result takes a lot more energy than a non-AI result. But I think in the end, we'll find that it's worth it, and we'll see that we've already seen like these protein folding type results of AI advancing science. And I think some of the science that it will advance will be in energy conservation and so on. And I think we'll see it as a big net positive.
I love it. Thank you. Well, very serious note. So we might end with a bit of levity. Yeah. The Lego Institute for Lego Investigation. I have to admit, I puzzled over it for a while. I get the sense that you have a sense of play, a sense of whimsy. With all of this hardcore research, how important is it to have a bit of fun? And what is the Lego Institute for Lego Investigation? What was the inspiration for that?
So my father was Danish, so I'm part Danish, and had Legos as a kid and enjoyed them, and likewise my kids enjoyed them. And then so we would kind of play with them every now and then. And it was at a time when a couple of my friends were starting up AI institutes. I think most prominently, Oren Etzioni, who I had known from grad school, was put in place as a leader of the Paul Allen's AI Institute. And so I said, I've got my job that I think is great, but these guys get a whole institute. So I want an institute. And then my daughter bought me this set, which was little Lego scenes of three famous female scientists. And so I said, oh, okay, now I have a research lab. So if I have a research lab, I should have a website. And so I put up the website and then just started adding to that. And I think I'm a little bit behind. For the first couple of years, is sort of every year I had one new research grant and wrote that up. But I think I've fallen behind a little bit.
I was concerned about tenure. I very much was. Look, it was a bit of fun, and it's just great to see someone who's had such a huge impact on some very serious topics around the planet takes the time to play with Lego and have a bit of fun. So that literally did make my day yesterday. Hey, if people are interested in diving more into your work, where can people go to learn more or to learn more about AI?
You can Google me and you'll find stuff. And if you Google me and don't find me, then you really have to contact me and I'll fix that. So there's a website at norvig.com. You can find me at LinkedIn.
There's some amazing stuff there. It's just incredible. And thank you for sharing all of your work, Peter. And thank you for joining us today. It's been an incredible opportunity to get
in touch. Pleasure talking with you, Paul.
Likewise. Well, that's a wrap, everyone. What are you doing to improve your AI literacy? We'd love to know your thoughts. Thanks again to Cloudera for hosting another episode of the AI Forecast. And thanks again for tuning in. We'll see you all next week.